Welcome to Exponential Functions, Part 2, and look at the exciting example that I am going to start with. So I'm going to take this thing and I'm going to try to graph it. Now, really helps if you kind of know what you're dealing with. You know, what's the basic function here before I threw all these different transformations at it. You know, the big picture is you got an x as part of your exponent, and you have a base of 1/3. So really what I'm doing is I'm taking this basic function of 1/3 raised to the x, and now I'm throwing all these different changes at it. So I'm going to go, well, I know what this function kind of looked like, and I can easily figure out the old points. How do I figure out the new points? Well, the way we do that is first, I like to rearrange things here. Like, for example, I like to add the 1 over. Okay, so I got my y plus 1, and then I got my base. Okay, now this, I don't like to leave negative 1/2 x minus 2. Whenever there's a number in front of the x in your function, you should factor that number out. So I'm going to take out that 1/2. It's going to leave me with an x, and now I got to figure out negative 1/2 times something has to make negative 2. So this should be a positive 4. All right, so that looks a little bit more the way I like to look at a function, because now it's really easy for me to say, well, what changes am I doing to x and y? Well, let's start. Actually, the y is the easier one. All we're doing is we're tacking on a minus 1. That's all we're doing to the y. We're not doing any stretches or compressions. You know, all we're doing is saying, yep, the effect on y here is a minus 1 effect. What about x? Well, the first thing I want to do to x is this timesing by the reciprocal. I'm timesing by negative 2, and then I'm doing this minus 4 effect. Okay, so there's my changes to x's and y's. And what I need to do now is gather up some key points, the old points, which means, you know, when I'm looking at the old function over here, this is the original sort of non-tainted function. What were some good key points? Well, there were some really nice key points, like when x was negative 1, when x was 0, and maybe even just one more is probably enough when x was 1. Now, if you have trouble remembering these old points, all you got to do is plug them into the old function, right? If you put negative 1 in for x, it's going to be like 1/3 getting flipped to the positive 1. So this is actually going to be like 3. Okay, now that one's a bit tricky. Maybe I'll just write it out so you can sort of see where that's coming from. Right? I've plugged in negative 1, and what I've done, a negative exponent, I flipped this guy, so it became a 3 to the positive 1. And that's why I just said, yeah, that's 3. When I plug in 0, I have 1/3 to the 0, which is 1. And when I plug in 1, I get 1/3 to the 1, which is 1/3. Now, those are the old points. So let's actually clear this out here. So I have room to put in what are the new points. So old and now new. Okay, what are the new points going to look like? Well, let's do all the x's first, I guess. Okay, so I'm going to times by negative 2. So negative 1 times by negative 2 is 2. And then I'm going to minus 4. So 2 minus 4 is negative 2. Then I'm going to go 0 times negative 2. So that's still 0. And then I minus 4. So that's minus 4. And then I put in the 1. 1 times negative 2 is negative 2. And then minus 4 makes negative 6. All right. So what about now the y values? Well, they're really easy because I'm just going to throw a negative 1. So all these numbers here, I'm just subtracting them by 1. So that's a 2, that becomes a 0, and this becomes negative 2/3. All right, there are my new points, and I kind of have in my mind what basically an exponential graph looks like. So I'm going to have to clear the screen here, so hopefully you got all these new points in your notes. I'm going to clear the screen and put up a grid. Okay, so now that I've got the grid, let's plot these points. Now, actually, some of my points are just really almost off the grid here, so we're just going to have to do the best we can. My first point is at -2 and 2. So this is my first point. Then I got -4, 0. Okay, and then I got -6. So let's go over to -6. And we're down at -2/3. So it's like down there somewhere. Now, what is going on here? Well, I can sort of see what's going on with this part of it. This is the, the curved shape going on here. So I think what I have happening here is that this is just, whoops, roaring up like that. And what about this? Well, I think this is just roaring along like this. Now, it might be a kind of an important thing is to identify, hey, where exactly is that horizontal asymptote? Now, remember, the horizontal asymptote, okay, used to be at y equals 0. And remember our y changes, we just went with -1. So if we shifted this as well, down 1, this is our new location for the horizontal asymptote. In other words, it fits what we've got, our little grid graph here. There's the horizontal asymptote, okay? So there it is. There is our graph of a very miserable looking function. Now, let's see how we're doing for time. I think we have just enough time. Actually, maybe not by the time I write out the question. So I'm going to stop there, and then we're going to make it a part 3. We're going to look at the next example. That way you can take a break if you have to.